introduce and explain common logs, which are just logs with the base of 10. And if we remember the fancy little mnemonic I used, we can remember the setup of logs and common logs, which is here. Large brats always exaggerate everything stands for the log, base, answer equals the exponent. We should also remember the question that a logarithm poses. What exponent must we raise the base to so that we get the answer? This question is also posed when it comes to natural logs. Natural logs just being logs with the base of e.
The number e, more than 2, less than 3, e. The number e, a constant transcendentally, it's e. The number e.
Now, like the song said, e is an integer between more than 2 and less than 3. I'll actually leave the link to that song in the description of the video if it helps. E actually is an irrational number, and by that I mean you can't simply put it into a ratio. Fun fact about e is that the complete value of e has not been fully determined, and they've only calculated about 869,194,101 decimal places of e, which is kind of a lot, like pi, but more irrational. Most people use the rounded form of e, which is to the thousandth place, 2.817 thousandths. Some people actually plug that in to their natural log equations, but that's kind of excessive considering there is a button on the calculator, and if that button on the calculator is provided to you, most likely you're going to use it. So, and since most natural logs do require a calculator due to the factor that e is irrational and not fully determined yet, we'll be using a calculator for this tutorial on solving natural logs. The time where calculator is not necessary is usually during conceptual questions, so let's get into it. So with a natural log, the base is always e, which is always the same constant, basically. Just like with a common log, e can be absent, how 10 is in a common log. They call that a hidden base. But just know that with a natural log, it's always e. Okay, we're going to go over here to look at the natural log setup, and it's just like any other logarithm, except this says natural log, and it's to the base of e. A mnemonic I used for this is lately Natalie establishes an eccentric essence, and it's just some corny mnemonic I made up. You don't really have to use that. You can make up one of your own. It just helps me remember it. And a natural log converts into an exponent the same way a common log does. The log with the base of this answer equals the exponent, and then the base risen to the exponent equals the answer. Same thing with a natural log. E to the power of the exponent equals the answer. So I mentioned conceptual questions, and those are pretty much by far the easiest questions. They trick a lot of people because I don't think they understand the basis behind them. So we can kind of start with an example of it. Okay, so a question that they might ask you will look like this, and basically they'd ask you to solve for x, or what is the value of x, and a lot of people get tricked up in it because they don't understand how to convert between the two. Basically, all you have to do is convert from a logarithm to an exponent using this over here. Base to the exponent equals the answer. So to the exponential form, it's saying this base to this power equals this. So e to the x power equals e to the 7th power. And a lot of people, I guess that's where they confuse that, but honestly you can just figure out that x does equal 7 because they're in the same place with the same base. Same place, same base. Yeah. What I usually try to remember is just like the definition of a logarithm, because it tells me that the natural log of e to the x power equals x. So the natural log of e to the 7th power equals 7, because you look at it like this: e to the x equals e to the 7. Since these two are in the same place, x must be 7. Okay, now we're gonna try one. We're gonna do, let's see, green. The natural log base e of e equals x. Now, what is x? Well, based on our definition, log of e to the x power equals x. So this is also e down here. So e to the x in exponential form equals e. To what power do we need to raise e to get e? Okay, so here we should get 1 equals x, because for any base that is greater than 0 but not 1, which pertains to e, the log of that base equals 1. So the natural log of e with the base of e equals 1. And you can check that. E to the 1st power would just give us e. So we can write, let's see, text box here, for any base b or e greater than 0 and not equal to 1, the log of that base B or E. B or E equals 1. Here, let's do it like this. The log of B with the base of B, there's same B here, equals 1. The natural log of E equals 1. Let's move that where you can see it. Here, let's erase something. Yes. Select. Okay, so there we go. Since E is greater than 0 and E is not equal to 1, because we said E is greater than 2, less than 3, it pertains to this theorem. Therefore, the natural log of E equals 1. Okay, so after we solve conceptual questions, we have to move on to the calculator part. So I'm going to be using an emulation that I found on the web to show you what I'll be doing with the calculator. And I guess you can find one. I just searched up TI-84 online. Got one. So okay, so we're gonna start off with a pretty easy one. Don't really need the calculator for it. I guess you can use it if it helps, like, to prove your answer. So I'm just gonna write the natural log of 1 equals x. And what I always do first is tell myself that there's an E here. So I'll write like little hidden E here. I always tell myself that there's an E there, that way I can remember that basically that's my base and I have to raise it to some power of x. And so what I do is I take E to the x power and equal it to 1, because 1 is the answer, x is my exponent, and we said the base raised to the exponent equals the answer. So now, okay, so think about it. We can use this same case, basically, for any base that's greater than 0, which E is, and not equal to 1. We can use something called the zero exponent theorem, which means that any base that is greater than 0 but not equal to 1 raised to the zero exponent will give you 1. So let's type that in, actually.